Good morning, good afternoon, everybody. It's past noon here, and today we're going to be doing modeling a Prestressed Girder bridge from top to bottom, right? Because we start with the deck, and we're going to be doing this for the next hour. It's going to be a kind of fast pace. I send you the link of these training documents that you were able to download, and you can follow me on the screen, or you just can watch me, and then later you can comply with this later. So at the end of the meeting as well, I will send you the link for the recording. I'm going to process this video. I'm going to be placing YouTube, so you're going to get a link for today's video and the previous ones too, to all the attendees of this session. We are more than 288. Thank you so much as well. So here we go, right? So now what we need to do, again, I am following this training guide that I give to you, right? I provide you the link of this, or you can just download it from the Learner server at Bentley. It's Introduction to OpenBridge Designer, right? And we're going to be doing actually the module 3. On the previous sessions, we did the do it with the wizard, right? So it was very quick and all of that. But now we are going to be doing the actual module 3 for that. That is precast girder to span straight model, step by step, right? So that is the one that I'm going to be doing. So then for that, I will just launch OpenBridge Designer. I will maybe create a new OBDX file to start the process from scratch. So let's call it the Ask Alex session for this, right? And I can pick the Beam workflow or the standalone workflow. I think on the wizard we did it with the standalone. Let's do the Beam workflow. Let's create the precast bridge, right? I will open OpenBridge Modeler and of course start the process, right? While the software is opening, you see that when you download the data set, I will just, to comply with the manual, I will put it on my C drive, Bentley training, Introduction to OpenBridge Modeler, Imperial, and that's where the module 3 files are, right? So basically what I do is I pick the proper workspace. That's important. We use the standard for this class, the Imperial standards, and I will create a new work set, right? A new work set that will be the location of my training files, for example, that are going to fall in line. So there I go, browse, and then I will open on the C Bentley training, Imperial, module 3, the precast bridge. This is a blank DGN file in which I'm going to place my bridge. So it's going to open that. Right? And while it's opening, right, let's access to this. It's loading all the libraries pertaining to this, and we'll see. Right, so I was going to use the Imperial workspace with this my project works at training. So now you have to design for a specific DOT like Florida, Michigan, right, Arizona. So you need to download the proper workspace for that. So it will include all the level libraries, the templates that we use, and so on and so forth. So file is blank, right? So we need supporting information, and that supporting information comes as it says on the manual on page 19, that we need to attach as a reference file, as a minimum, the geometry, right? And also the terrain. These are the two, I would say, minimum ones that you can attach. We can also attach the corridor that it came, right? And let's do that, right? So I'm going to use the coincident word, and on the fly, I'm going to do geometry. I need the geometry, I need the corridor, and then the terrain, right? So I just do that and bring all that information in. Right, so that's basically what it's saying at the beginning of page 19 in the training manual. And when I do fit view on both sides, so then I get the project, right? And that is that gap, right? That is where my bridge is going to be, right? So as I said, we did it with the wizard on the previous session. Now we're going to do it from zero, right? So not using the wizard, but then going through these icons here to develop the bridge. So I will add then a new bridge, still on page 19, add a new bridge, and it's going to ask me when I add a new bridge to select the alignment in which that bridge will be placed. So that's the dialog box here. I will put a description, you know, it's my PC bridge, precast bridge. Important is going to be, yes, a precast bridge, right? And it's going to start with the name bridge. And that is going to be the alignment that I'm going to use. Don't click here, nor here, right? This is a specific case in which you have a center line alignment. We call it the roadway alignment, and to have two parallel bridges. Usually that's not mostly the case. We run the alignment along the bridge center line, right? So don't get confused by this. So I just go and select the bridge. And that's my bridge name, accept it. So now internally, I already have a bridge. Also, what I can do, since I attach the ground information, I can make the ground the active element of the bridge. So select it. Now I have a bridge, and then everything becomes now 3D. So this is how we're going to place my bridge. Right? You see there is some stationing happening. So if I want that station, so I can just go here to analysis and reporting and say, look, I want to see the station. So since the annotation scale is dynamic, let's try 150 scale. Okay, that will do it. Right? So that finish it with page 19 on that training manual. Right? So now let's start placing the support lines. Right? So I'm home. So I finish with all of these. So now I'm going to place support lines, and I'm going to place it 3 support lines because this is a 2-span bridge. So 3 support lines. And on my dialog box, it says the skew angle is going to be 0, right? It's going to be perpendicular to the alignment. Or if I follow strictly the manual, it says it's going to be an 8 degrees. Or no, I'm going to put it 0, and then I will show you something that the manual doesn't show. Anyway, right? So the length is the length of that blue line that you see enlarging on my screen. So I will just say, just for display purposes, I'm going to fix it to 200. The manual says 100. Oh, I like double the size, right? So I can pick it easier. Start the station. I can hard code it, eyeball it, or hard code it with the click here, right? So the manual actually hard codes this. So it's 114 plus 67.5, right? So that, and I'm going to place 3 support lines with a span length of now 110, right? So, and it's locked. So I'm locking the beginning and say it's 3 support lines on that direction, 1 data point there, and I have my 3 spans. My 2 spans, 3 support lines, right? And then it prompts me to this screen that plays multi-support lines, the modification. I will say okay, because if I want to access it again, I can go modify one more time and then really comply with the manual, because the manual says, no, it's not 0, it's 8 degrees, all of them. So I can change that, right? So you can edit this at any time. You can edit the span length. You can edit in the stations if you want, right? So just I wanted to show you that tool, that you can do it way after the fact or at the very beginning. It's all up to you, right? So Yes, that. So that's it. Next step. So very quick, I finish with page 19, 20, 21. Yeah, that's what's supposed to be seen on the screen. You see that text. Changing that. So again, you can modify it here. So next, model the bridge deck, page 22. So on that, then I will move forward and say place deck. Right? So on place deck, dialogues try to move to outside my screen. I need to pick the template name. So on the template name here, we give you a series of templates, right? That you can customize as well, right? Or you can say, pick that one, slab with constraints. That's the one that we're using, right, for this class. But then it says constraints because internally, you, the software, you can add it to certain variables that allow me to modify the width of the deck, the thickness, and all of that, right? So that's what it means. So I just selected, again, I'm not knowing yet the width of the deck and all of that, but hey, I will use it. And then, of course, as well, that yes, these constraints need to be defined. So I will add the constraints. This is the main deck of the bridge. So it's not an approach slab or anything else like that. So I want it to become an analytical deck. So it means that Leap can calculate it, right? And from my material library, right, I can pick that the material name that is loading is a deck concrete, right? So for the purpose of quantities, this will serve me well. Remember, I add the constraints. So I say my deck goes from beginning, left click there, to the end, left click there, and add the constraints, yes, because I want to modify the following. And it shows me another dialog box right here. And that following means that, hey, I need to modify the length of the left lane, that by default is 20. And I also want to modify the width of the right lane, that by default is 20, but I want to modify it. So let me come back to this and say, yeah, by default is 20 all across, but no. Left click, and it says that according to the manual, one more time on page 23, is that this is going to be a 44 feet deck. So on the left is starting at minus 22 and finishing at minus 22. I think you got the idea that if you got a variation on deck, on width, for example, a tapering deck, one of the easy ways to do it is by a station, adding more stations and tweaking the numbers here. And on the right lane, you can do the same. Left click and say now it's 22 and 22. So saying that, accept it, right? The default is not going to change. It's still the same. It's just here that you're tweaking this 22. That's it. You got now a 40-foot deck in top view and in your 3D view. As you can see on the constraints, you can change anything that you need. Right? So that will do it. Now I got some questions. Okay, so that will do it. Is there a way to make the structural deck thickness different than the Pore deck thickness? Well, for the purpose of geometry, I would say here is the full deck, right? Because you want to report deck elevations there. But also remember that when you go into design with Leap, there is an option to do sacrificial thickness and then the actual change thickness of our structural analysis there on design, right? So that's what you mean by the sacrificial wear, right? Here, if you report the 1.5 as part of the deck itself and then provide deck elevations, then you have to do the full deck thickness, right? 9.5, as Devon is asking here. And then on LEAP, you can reduce that to make it a concrete, structural concrete thickness there, right? So that will be on the analysis part. So that's how you can do it, right? So that will be it. Now, then after that, right, we can continue. Yeah, there's time, Manuel. Manuel, I'm going to show you how to cut a section very quick. Now, next step, beam layout, right? So I finished with this place deck. So then I will go to page 25 here and go beam layout and specify here that my beams are going to go from this first span to the last support line, I would say, and accept it, right? And on that, it's going to, that basically is going to say, let me enlarge this. Okay, how many beams do I want, right? Are they going to be all the same in all the spans? Yes, that's default. I cannot place this yet. Okay, I want 5 beams, right? And the distance from the deck is going to be 3 feet, 3 feet. So it's going to be an equal distance of 3 feet. See, it's clearing up. The separation is calculated automatically too, right? And they are all the same at the beginning, at the end. Easy case, right? We can explore later how to do more complex scenarios of flare beams. Now you can change the beginning and end values of this, so you can flare one of the beams. Even you can make the beams follow its own alignment too, right? But then this is a simple case again, right? Not only that, but the SL offset, support line offset, is the offset of the beam against the support line. And you will see what I mean by that. So I put 3 inches there. And be careful with the units. Some of the units are in the big ones, of course, like spacing is in feet. These are in inches, right? So I will say the beginning and end is SL offset 3 inches. And I'm going to show you what does it mean. So 3 inches at the beginning, at the end. There is no red marks here. So we're good. Just validate just in case, right? There's something missing. No red flags. Save it. Right? And then, right, these beam lines, we also place it, not only place it in 3D, because we place it actually in 2D or elevation 0. Why? Because you can use it also to produce some plans there. Somebody said framing plans? Yes. Right? Now, what does it mean that SL offset that I just placed? If you take a look at the support very, very close, you see, this is where the beam is going to end, and this is where the beam is going to start. And that gap is 3 inches from here and 3 inches from here. That is the support lines, SL offset that we're talking about, right? Because if we put 0, basically your concrete beams will start and end at the same place. And now then we went down, right? So that's what it means, that SL offset. Next step after that is just continue, is just, I would say, place the beam, right? So let's go ahead and place beam, right? And let's bring the dialog here. And I'm going to say, I don't want any beam rotation. That's usually done on U beams, right? And then say, I'm going to be place these beams along this beam layout. Accept it. And then select the type of beam that I want. So it's looking for it. Dialog box right here. And say it's going to be coming from LEAP. And the type of beam, if I follow the manual, but it's going to be the PCBTs, Girder, precast, Wolfty, way at the end. 61, right? That's it. So it picked. Now here, hunch, beginning and ending hunch, right? You can do that. I would like actually deviate from the manual a little bit and say, you know, I'm going to use 1.5 inches. Manual says 1. and expecting camber of 3. What does it do, right? This is a very powerful feature if you think about it. It will read the profile, alignment and profile as you're placing the beams and their location, right? And it's going to establish at the most critical location a minimum clearance of 1 inch, if we're going to comply with the manual, between the top of the beam and the deck, right? Thinking that I'm expecting a camber of 3 inches. So it's going to regulate the beginning and start of the hunch at the beginning and end of the beams, trying to achieve that minimum clearance of 1 inch at the critical elevation along each beam. So if you later calculate and you get a camber of 2.8, well, good. We calculate with 3, I'm safe, right? I don't need to do any more checking of the deck elevations and the top of beam elevations, right? Now, if I get a camber of 4, to say something, so then, well, then I may need to recalculate that option, right? So that's that. So again, very powerful, because if you don't use this option, you can make guess what is the beginning and minimum hunch that you can apply at the beginning and end of the beams. But then, yeah, you got to calculate what is the clearance that you got between the top of the beam and the deck, or the minimum hunch, we call it, according to the camber that you set. So this is more of a proactive approach, I would say. Right? So saying that, I can continue with this, right? And say, well, okay, because the beams are already there, or will be there, sorry. Yeah, Denison, can OBD detail variable deck thickness? Yes, he can do that, because remember, the same as we generate the width of the deck, a variable, if I will activate thickness by station, I can just go different thickness along the alignment of that bridge. So yes, I can do that. It's just a matter of applying the proper variable to it. However, LEAP will not calculate that, because LEAP it doesn't handle variable thicknesses. So it will use the minimum thickness to do the calculations in LEAP. But modeling, yes, you can, and it will provide you as well with the proper quantities too. Okay, now another question here. Can we export the OBM file to Microstation? You don't need to. This is Microstation. Okay, you can modify it here, Elmira. So you can do it here. I mean, you can just go into the modeling tools, just to not deviate too much of the subject, to the modeling tools. And if you really want to model, you can apply all the solid commands and all of that to really tweak the bridge. Careful though, because you will kind of lose the parametrics. But yeah, you can do it. This is Microstation. There is no need to export. This is built on top of Microstation. Oh, Steve answered it already. Okay, so my colleague is here, so he will answer it, all your questions too. If the deflection we'll get from lead bridge can be reflected too. Yes, when we go to camber, there is an option to bring that camber in. So we will do this in later sessions in which we analyze the geometry of this happen. All right, let's keep going. Let's go with the pier then, right? So I place beam, so now let's go place pier. Okay, so I'm on page 28, if you want to follow me on that. So I pick a template that I need, right? So that template is on the library that you know you can modify it. And right here, right? So let's say this will be the closest one that I need, maybe, right? Don't get tricked by the dimensions. It's just a reference, because we can just go in and modify it on the fly and create a template for this. So I would say this is the one that closest to it. So I will just select it, right? And even I will do it dynamically and say, look, adjust the cap length by the deck itself. So maybe I develop this template with 30 feet cap and then say, no, my deck is 44, enlarge it automatically. So this will do it, right? And then also, I want you to make it react to the ground, right? Because the footings need to be a certain depth below the ground. And remember, I attached terrain to it, so I want to make it reactive too. And then apply the materials to it. So going back to my library, right? I would say, okay, this is the material that I want to use, substructural concrete for the cap, the same for the columns, right? Sorry, my dialog box is just going always to my main screen. But you get the idea, right? So I just kind of go and select it here. And then right here, one more time on my library, right here. Done. Right? And then saying that, say, okay, select the support line. So right here, that's the support. Accepted. There is no more support lines because the other ones are abutments. So right click to end. Right? Remember that I place the elevation constraints and say yes. Left click. Yes, I want my cap to be leveled, right? A straight cap. But the footings, I want it to be, I think the manual says -5, if I'm not mistaken. Oh, -5 will be good, right? Or -3 says the manual. I'll put -5 anyway, right? And apply to the footings and just hit OK. Just hit OK. My footing will come up. Done, right? No more support lines. Right click to reset. Even doing that, I can just go to the footing itself. If I follow page 30 on the manual and say, look, I can modify the pier. Select it, let it to activate the context menu here. And I got a lot of options to do. Elevation constraints. I can actually go and even modify the template itself as the manual is doing. And say, you know what? The columns that I place, the cap is different. I want the cap to be rectangular. Okay, let's make it rectangular, right? Cap height is different. It's 48 and 48. That's what the manual is doing. So let's go ahead and modify. You see how it's on the fly modifying, right? Just like that. And the columns, yeah, the columns are different too. I want to be circular, but are going to be 42, for example. So I can change it to 42 and 42 right here, right? So I can add a third column if I need to. I can put piles to it, right? But so I think you get the idea, and then you can just follow the manual into that, right? So if I make that many modifications, I can even add these new to the library. So I can just do that and say, look, I modify this, so I can just select and put a name to it. That is the ask sessions, right? Session peer, for example. And then I just save it so I can just use it later, right? And then I forgot to attach it. So then, hey, no big deal here. I will just go here and say substructure template. Since I didn't hit OK to these modifications, I can just go and say switch template. On that switch template, I should have there the new one that I just created. And then now I select it, and what I forgot, hit OK, and then I have my new template right here. Okay, so following the same on this, I will just go and place the abutment. I think you know the mechanics now at this time, right? I can just say, okay, now I need a template for the abutment. So let's do a pile cap, right? And the manual is picking this, right? Selected. I want to adjust it by the deck length, right? Just to avoid myself extra work. I don't know the height of the back wall because of the size of the beams, right? So I just say, do it automatically. Match the back wall height with the deck top, right? And that's it. So then I can attach the materials, as you may see me doing here. This is kind of a repetitive process, right? For the cap and the column and all of that. So I'm not going to do that. Then you know the mechanics of this, right? So then saying that, I will say, okay, this is what I wanted here. Left click, accept it, done. And then also on the other side, left click, accept it, done, right? So now if you look at this, now I have my abutment there. Just for cleanup purposes, I'm going to turn off in the reference file, the corridor, so you can see what I have, right? So that is in 2D, that is in 3D view. Maybe if I want to make it a little nicer for the eyes here, I can just go to transparent view. And that's, see the deck top is checked already and the beams are there. So, well, I got my bridge almost done, right? Because what I'm missing is the bearings, right? I place the abutments, I can modify the abutments, I can do piles too, but then I will just finish here and move on to place bearings, right? So on place bearings, before I do that, let me just move my screen a little better right here. So again, one more time, place bearings, right? And just select what I want to place. I want to place a cube. This could be the dimensions of that bearing, right? If I follow the manual, I just have to key in these numbers, right? Oriented by the pier. It has a bearing seat, right? Wait a little bit too, right? But then I want to model a step cap for that. So it's going to adjust it automatically when that height changes to this, right? And then the offset, so that bearing will be placed at -1 and 1 foot from the beginning and end of the beams. Right, one more time, I can pick the material from my library, right? So it would be a neoprene pad, for example, right? And that's it. So now the next step is to say, I want supports, left click, and left click, right? If you don't see the circles, right, it means that something is wrong with your dimensions and the bearings will not be placed. If it's done, so reset to enter. So meaning right click, see the offsets, look what's going to happen here, accept it, and then everything will be moved to accommodate for the step cap, bearing seats, and all of that. All right, you got it. Right, so what else is missing here? Oh, the barriers, right? So with that, man, we're almost done. We place barriers here. So place the barrier. Say what type of barrier you want to place, right? These processes have to be done twice for the left and the right. So I'm going to be biased here. And since I work from Miami, I'm going to pick a Florida barrier, right? So I'm going to place one on the left first. No offsets. I'm going to pick the material one more time from my material library, right? Let's pick Alex Concrete, right? And then just say, what is the candidate? See, select candidate. The candidate is the top of the deck, right? So I just select the deck. See, it becomes highlighted. Accept it. There is no more decks. Reset to end the selection. So right click. It shows you this kind of click here. So just click it. Left click. And then it's going to ask you for the working point, where to snap on the deck for that barrier. So I will say select guideline from the list. So remember the deck constraints, the points of the deck, right? And this is the left deck. So I should place it, right? So you can see it clearly along P5. If it's the left barrier, it should be placed, you see, along P5. Okay? Okay. And you got your deck. Right? And I do exactly the same procedure of place barrier on the same candidate, my deck. I click accept it. Oh, made a mistake. I forgot. I have to switch to now the right barrier. Right? It's not left anymore. I need to pick the barrier on the right side. And now I can say, okay, that is my candidate. Right click to accept it, left click here, and the guideline from the list will be P1. Now, you know the drill. If it's a median barrier, that will be on P0, right? That is the center. So saying that, done, and you got it. Right? So can you add more stuff? Of course you can add more stuff. I mean, even if the manual doesn't cover this, now you know how we pick stuff in, right? So you can just, for example, add wing walls. Let's be bold and add some. And the mechanics is exactly the same. You want a left wing wall? Yes. And if is that the case, what is the template name? So one more time, you can just go and from the library that we provide, pick or modify the dimensions to, like that, for example. And that's going to be for the left, right? Align with the abutment? Yes. No offsets, for example. Skew angle, you can change it later if you want. Do you have a right wing wall? Usually you do. What template you want? It could be the same. It could be even different if you want, right? So let's pick the same, right? And the skew, you can even adjust it later, right? Adjust the height to the back wall on both. Yes, you want to match the back both too. So a lot of settings, right? And oh, wing wall materials too. I think you know what I mean by that. You can just attach all the materials needed, right? I'm not going to repeat it for all of them, and you know that you have to do it, in this case, 3 more times. And then say select the abutment, right? So select the abutment itself. It knows, accept it, and you got your wing wall. And then I can go to the other one too. Select it, and you got your wing wall. As you have it, right? Remember, there is a straight, right? All aligned and all of that. You can just go to each one of them now. Say, no, 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 I made a mistake because now the angle is different. So it's minus 30, for example, and see if it rotates the way I want. Yep. And see how it aligns. So you can just do all of that. So just little by little, you can have your entire bridge done there. And you can review the contents of your bridge if you go to Explorer and on your bridge model, you can see what you have. And that is all the information that we just generated. Right now, what's the level symbology of the beams and all of that? Yes, we do that. Okay, don't get me wrong. We know certain levels and all of these. But remember, now we're driven by features. So what you can do, you want to clean up certain displays and all of that. For example, say, I don't want to see the beams. So what levels are they? So the temptation will be to go level library or turn off. You can just do this too. That's it. You don't see the beams. I don't want to see the footings either. So where are footings here? Supports, no supports. Right? I don't want to see the wing walls. You see what I'm getting left out? Right? Does it remind you to kind of framing plan? That's how you can start composing this. Right? There are so many different ways to do it. Don't get me wrong. Right? But hey, that could be one way to do it. See, you don't want the barriers either, right? So where are barriers? Right here. So what you're left with, if I even took out the support lines, what is this? Your framing plan. And then you can just turn off the text here, you got it. So there are, as I said, many different ways to compose the information that you want, right? And put it into sheets. Maybe this will be a topic of a different session in which we can explore the many different ways to do plans production, right? So now you want to check very quick what you have done, and then how the typical section goes. You can just go here and just cut a dynamic section and say, look, I want to strike a cross section this way with that angle, with that depth. And I want to create a sheet model or just a drawing to see what it looks like. And just done. And that's the typical section that I just created. Right? In a more elaborate fashion, I can just come back through here, right? Say, look, I want to create a real typical section, right? Perpendicular to my alignment with a sheet, and just call it typical, for example. All right, and got it. So it's doing twice because what it's giving you in the drawing, it's text dimensions. On the sheet itself, it's just doing that. So what you can do then is move the reference. Oh, what I did is was pressing the right click, holding that, it activates this menu. Then I just go move reference and just put it there. So now you have your sheets there. Right, so that's, I would say that will complete the modeling of the bridge as I promised for this session. You know, we took what, 40 minutes to do it, explaining, following the manual. So you don't like it, hey, you can just delete it and do a complete different bridge, open a different file, reference it and do it. So now I think you know two ways to model the bridge, either the more detailed way, the long way, if you want to call it like that, or using the wizard. Right? Later, we can explore again more options on plans production and all of that. But I think for today, I want to leave you with this. You got the training file to follow it, and the recording will be up there soon as well. Right? So I'm going to stop the recording now. I don't know if Steve, you answer most of the questions. Feel free to jump in. I'm going stopping the recording now.
Yeah, Alex.